Welcome back to the day one solving system graphing notes. This is our second video. Just want to recap that with solving a system, we are working with two or more linear equations as we saw yesterday. And with that, there's two or more variables, in our case, an x and a y. So hopefully you got a good introduction yesterday. You're starting to understand these a little bit. And we're on example 4 now. And the challenge that they're going to give us today, they're going to have us do the same types of problems, but instead of giving us something in y equals mx plus b, it's going to be scrambled. We have to unscramble it. So for this first problem here, I want to kind of split this a little bit. Remember, we are trying to create, I'll write it way down here so it's out of the way, a y equals mx plus b. So I will split this one. Our goal is to have the y on the left have the mx plus b on the right. On this first one, we can see we do not have this. So guys, there's an invisible plus 1 on this x, and then if you want to think about it, this is a positive 9. In order to move that positive 1x to the right side, I need to do the opposite, which is subtract 1x. These will cancel, leaving me a negative 3y equals negative 1x plus 9. Notice I am not making an 8 here. I want to have, back down here to the bottom right corner, I want to have an mx and I want to have a b. If I put those together and make an 8, I would only have one item. I would not have both of those items. Last thing I need to do is get y by itself. Divide by negative 3, divide by negative 3, divide by negative 3. These will fully cancel out, giving me y equals a positive 1/3. Negative divided by negative turns positive. And then 9 divided by negative 3 is negative 3. So my m for this one is going to be 1/3, which is my rise over run. And my b is negative 3, which is my start on the y-axis. So at this point, the problems are exactly the same as yesterday. Just some work we have to do there at the beginning. So I'm going to start at negative 3. Let's remember our y-axis goes up and down. X-axis goes left and right. And negative 3 is going to be 1, 2, 3. I then have to go up 1 to the right 3. And I will follow this pattern all the way across the graph. I will then follow it backwards, and I'll make my line of dots. Remember, we're not connecting these dots, guys. We need to see which dots overlap. It's easier when we just leave them as dots. Looking at my next one, I'm going to split this, guys. Once again, the 2x, it needs to go to the other side. So I'm going to subtract 2x. I'm going to subtract 2x. When I do that here, I'm going to be left with y equals negative 2x plus 4. I did not make this a 2. Once again, we have to have both items down here. So do not put those together. At this point, I'm actually already done. I can see that my m equals negative 2, which is my rise over run. By saying that, that tells me, hey, I need to put a 1 underneath here. I need my run part. My y is my b, so b equals 4. This is my start on the y-axis. So I'm going to start at 4. So I can go up 1, 2, 3, and 4. At this point, I'm going down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. I can see that this is my dot that is going to give me my answer. I like to put all my dots on there, guys, to show truly where the lines are, get a little bit of a better visual. So I'm going to follow my pattern in both directions and get those all the way on there. So this solution, we can look, is at 1, 2, 3 on the x, and it's at negative 2 on the y. So this is 3 comma negative 2. We need to know that means x equals 3 and y equals negative 2. So we have our solution here. Not much different there, guys, except for the very beginning from yesterday. So hopefully this new part is something you can focus on and get accomplished, and then not be so stressed out on the second half of these problems, since it's what we did yesterday. Now, they are going to throw some real-world problems at us, so example 5 is our last example. We'll take a little bit longer just because I want to make sure you guys are understanding what exactly is going on. So this says Kelly babysits on the weekends. One of her customers, the Smiths, offers to pay her $10 plus $1.50 every hour. Then it says another customer. Before we get to the other customer, this is the first thing you need to understand. The Smiths is one family. So that is one of our equations. So I'm going to think of this as equation number 1. Remember, we're working with 2 equations in these problems. So now we get to the end. It says the Browns will pay her $4 per hour. So since the Browns will pay her $4 per hour, it's a different family. It's a different scenario. That's going to give me my equation number 2. So when you get a word problem, you have to see the 2 different parts. Don't think that this is just one huge big problem. It's 2 different problems. We're going to be graphing 2 different lines, and we're looking for where they intersect. All right. So on this, guys, they want us to write a system of equations. So that means you write down equation number 1. So in this case, we're going to have y equals $1.50x plus 10. And for the second equation, we are going to have y equals 4x. And they don't give us a second number here. So with this, they only give us the $4 per hour. Since they don't give us any other number, if you want, you can put a 0 in here. If you want to just leave the 0 off, you can as well. So how in the world did I just write those? This comes from our last test, guys. Hopefully you are not forgetting this. The word per is a keyword. That keyword tells me its slope. So M goes with the word per, each, every, or rate. And since I know that slope is the letter M, that is the letter that comes in front of X. That's where I got my information to put the $1.50 in front of X, put the 4 in front of X. All right, and then also the other thing that you need to notice is this is a 2-number problem. Okay, they only gave you 2 numbers. They gave you the number 10. They gave you the number $1.50. When it's a 2-number problem, all right, what we said from our last test is you immediately find M and B. Well, if we found M because of the word per, that means the other number has to be B. And then when we're talking about the Browns, you'd be like, well, this is a 1-number problem. You only gave me 1 number. Yes, this one is tricky, guys. They only give you 1 number, and it's because the second number is nothing. They don't pay anything up front with the Browns. They just say, hey, after the first hour, we're going to give you $4. We're not going to hand you any money just for showing up. And so in a way, yes, they're giving you 2 numbers. The second number is 0. It's just a little bit harder to think about. So hopefully that's coming back to you from the last test. So we have here graph both equations. We need to first set these up. We need to know what our units are. And our units here are dollars and hours. Hours is going to be our X variable. It's an amount of time. So I'm going to label this hours down here. And then I'm going to put my dollars for the Y. I need to pick numbers. With this, guys, we need to make sure that we are getting high enough in our numbers to satisfy everything. This is going to be $4 per hour, $1.50 per hour. So with that, guys, you need to think, how many hours will we probably babysit? On this, it's kind of hard to guess, but thinking about it, usually you babysit for some parents maybe when they go to work. Most parents are at work for 8 hours, maybe 10 hours, so I'm thinking that's a good number. That's my guess. So I'm going to choose to go up by 1s, but I'm going to skip a space every single time. And then that X is kind of in the way, but that would get me the 10 if we end up needing 10 hours. Now with the money, with the Smiths, we're going to start off. We're there for like 1 second and we're already at $10. And then we're going to make $1.50 per hour every hour after that. So we probably need to get up a little bit higher than 10. I want to make sure that I get up to 20. I think doubling that would probably be good. So when we go up here, I'm going to probably go by 1s again, but I'm not going to skip any spaces. And I'm just going to write all the even numbers on here. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, and then 18. That'll get me up to 19 at the very top. So hopefully we don't need to go any higher than that. So we still need to graph these. I'm going to look at equation 1. I'll keep it in red. It's going to have me start at 10, so I'll be at 0, 10. They start at $10 just for walking through the door. And then you go up $1.50 every hour. So my rise over run, I need to put a 1 underneath there. So I'm going to go up $1.50, and I'm going to go to the right 1. And then I'd go up another $1.50, and I'd go to the right 1. Then I'd go up another $1.50, and then to the right 1. Up another $1.50 to the right 1. And then I'd go up another $1.50 to the right 1. And I could go up another $1.50 to the right 1. Hopefully, we do not go past 6 hours of babysitting. If we do, I'm going to have to unfortunately fix my graph. Going to equation number 2, once again, we're going to have to put a 1 underneath here, rise over run. This one's going to have us start way down here at 0. All right, you don't get any money from the Browns just for showing up. But each hour, look how fast we jump. We're going to jump up $4. Then after 2 hours, we jump up another $4. Then after another 4 hours, another hour, we jump up another $4. Then we jump up, well, boom, right there, we hit. We can see that we're the same. And if I jumped up another 4, I'd actually fall off the graph a little bit. I'm going to put it there, but it's a little bit higher than the graph. So we can see that we have now found an answer. So on C and D, they are going to ask some questions here. For C, it says when, meaning time. When will the pay be the same? And we can see here at 4 hours, that's in line with where we circled green. So this will be 4 hours. And then it says how much, meaning money. Would Kelly earn? Well, that is with the 16. If she worked there for 4 hours, it doesn't matter if she worked for the Browns or the Smiths, she's going to make $16. So they're going to ask a question down here at the bottom that says, what advice would you give her to help her decide which job to take if she only is going to babysit for 3 hours? I'm going to give myself a little space here. I still want to be able to see this graph. On this, guys, if she's going to babysit for 3 hours, well, let's look at 3 hours and see where the 2 dots are. If we go up, just like we had with the scatter plots from the last test, with this blue dot, she's going to make 12. If she went up to this red dot, she's going to make, what does it look like? It'll be a little bit over $14, $14.50. So I would want to do the red dots, and the red dots went with equation number 1, which went with the Smiths. So I would choose the Smiths because you make more money. So on this, guys, I know a lot of people ask, when am I ever going to use this in real life? Systems of equations are used constantly. Anytime you compare money at lunch, a vending machine, with friends, whatever, you're technically doing some type of form of systems of equations. You may not be doing it as mathematically as this, but you are still figuring out those patterns. So guys, this will help us finish up the day 1 worksheet. We will be grading this. So make sure that you're getting everything completed. And if you have questions, you get stuck on a problem, you're asking me or somebody else in class.